Hello everyone. I just want to tell you before I get started lecturing on this that you can pause this, rewind it, do whatever you need to as you're going through it in order to get the notes. So if you need to pause it and write the word, please do. You can always push play to continue. Okay, so to review, we're going to start off reviewing just atoms in general, and then we're going to get into the periodic table because it's all connected. So our review here is the atoms. They're the smallest piece of matter. So remember, in terms of chemistry and science, that this is the smallest unit that the most of the science is based upon. Now, these atoms are made of 3 parts. The parts contained in the nucleus, the one with the positive charge is a proton. The other one in the nucleus that is neutral or no charge is our neutron. Okay, and then moving around the nucleus in a cloud or an orbit, we have the electron, and that has a negative charge. So I think all that is just kind of memory, and I'm hoping that's familiar. So this time we're going to draw a carbon atom. So in the middle of our carbon atom, we're going to draw 6 proton. Now I know that there are 6 proton because when I look at the carbon on the periodic table, it has 6. So I'm going to explain how we get those numbers by the end of lecture, but we're just going to start by drawing an atom. So I have 1, 2, 3, 4, 5, 6. I'm going to make these positive because these are my protons. And then I also have 6 neutrons. So I'm going to go 1, 2, 3, 4, 5, and 6. And those are neutrons, no charge. They are totally neutral. And then surrounding this, I would have some shells or orbits. So I have 1, 2, hopefully your orbits turned out a little bit better than mine. But hopefully you again remember from the first time we did this, that in the first shell, we only have 2 electrons in order to be full. So I have 1, 2 electrons, okay? Then, in the second shell, I can have up to 8. But since its atomic number is 6, I need 4 more electrons. So I'm going to put 1, 2, 3, 4 more electrons for a total of 6. So 6 protons, 6 neutrons, and 6 electrons in carbon. Now, those electrons, they fly around and they move in shells. So it's a little bit better picture here. Here's our electron clouds or shells. So it's easiest for us to think of it like a planet, like it orbits around. Technically, that is not correct. Technically, it is 3D. It could be anywhere in this whole sphere around there, closer to the nucleus, farther, anywhere. But for our purposes and what we're doing, it's just easiest to think of the electrons as moving around like the planets do around the sun. Okay, so in these orbits or these shells, we turn your paper over. There is a maximum number of energy levels in these shells. So in the first shell, like we were just talking about, we have a maximum of 2 electrons in the first shell, okay? In the second shell, we have a maximum of 8 electrons in the second shell. The third shell, a maximum of 18, and then the fourth shell, a maximum of 32. Now, just for a little sideline, just so you've heard it and keep it as future reference, these, yep, you should be writing this, they only need 8 electrons to be, yes, and we are giving them traits, happy, okay? Whoops, they only need 8 electrons to be happy, okay, in the second and higher shells. And we'll talk more about that when we talk about bonding in general. Okay, so we reviewed electrons, protons, neutrons, electrons. Now let's talk about the periodic table of elements. So elements, they are arranged in 2 different ways. They're arranged by periods and groups, or they could be called families, those groups. So a period is a row, and a row means it goes across, so this way, And there are 7 rows on the periodic table, okay? And then the other way that the periodic table is grouped, or is groups or families. So these are columns, and these go up and down. So these go up and down, okay? And in these columns or groups, there are 18 groups or columns, and they're arranged by similar chemical properties. So things they have in common, the way they behave, they are arranged by similar chemical properties. So elements grouped by type. So special elements here are hydrogen, and which is 75% of the universe is hydrogen, and helium, because they have their own groups. That's why they're considered special. So let me just show you here. So here is hydrogen all on its own, number 1. Here is helium, number 2. They are their own little special groups. And hopefully you noticed they had their own color when you looked at your color periodic table for the quick write. Okay, then we have other groups. So we have the metals, and those are things like gold, nickel, iron, okay? We have the non-metals, and these are things like carbon, chlorine, nitrogen, and then you have the metalloids. Oops, sorry about that. Metalloids, this should be an A, T-A. Okay, so that's like silicon, boron, arsenic, and they're called metalloids because they behave kind of like a metal and kind of not. It's a little bit of both. So now let's talk about the periodic table and what does it mean and how do these words, what do they represent on the periodic table? So here's one box off the periodic table. So we have the carbon there, okay? And if you look on the periodic table, carbon is right here, number 6. Okay, so it looks pretty much the same as the number that I have here. So the first thing I'm referring to is the atomic number. So this is the number of protons in the nucleus, and it's the same as the number of electrons. Here we have the symbol. So this is a letter that represents the element. Okay, so it represents the element. And sometimes this is the Latin name, not the English name. That's why the letter doesn't match the first letter of our name. We also have the name on there, so that's just its common name right there. And then we would have the atomic mass. This is the mass of the element or the weight. Now, I need to tell you what all of those mean and how to use them. So let's back up just a little. So the atomic number represents the number of protons and electrons. Okay? The atomic mass, we use the atomic mass. So this number right here, okay, we use that to determine the number of neutrons. And how you find out the number of neutrons is you take the atomic mass, so our atomic mass, and you subtract the atomic number. So we subtract the atomic number to get the number of neutrons. And remember that atomic number is also called the proton number. So it's the number of protons, number of the atomic number. So the atomic mass is measured in atomic mass units, just in case you're wondering. Those are AMU's atomic mass units. And the symbol does not always, is used to identify the element. Oops. It's not always used the first letters because sometimes it is the Latin name. Okay? All right, so what we're going to do now is we're going to practice finding our number of protons and neutrons and electrons. So here is our carbon. So number of protons is our atomic number. So I have 6 protons. The number of neutrons, if we look up here and you remember, is the atomic mass minus the atomic number gives us the number of neutrons. So I go 12, and for our purposes right now, we're just going to round it off to be 12 minus 6 is 6 neutrons. So I have 6 neutrons for this one. And then the number of electrons is also represented by the atomic number. So I have 6 electrons. So if you need to rewind this and review, please do. Refer back to your notes. But I need you to work on the rest of these 4. Find the number of protons and neutrons in each one, please. Thank you very much. Have a great day, y'all.